All right. So in our previous class, we have done some questions on the conic section, including circles and parabola. And before that, we have been doing statistics for a couple of days. So now we will be starting with complex number. Have you already done this chapter in your school, Priya?
Yes, sir.
So today we will, I'll start everything from the beginning so that you can get better insight. See, equations like x square minus 1 equals to 0 can be solved with a result like x equals to 1 or minus 1. All right. So x square minus 1 equals to 0. So value of x will be 1 or minus 1. Similarly, if you have like x square minus 3x plus 2 equals to 0. And if you factorize it, you get x minus 1, x minus 2 equals to 0. So x will be 1 or 2. All right. But in case of the equation is like x square plus 1 equals to 0. In case equation is like x square plus 1 equals to 0. Now this equation cannot be directly factorized because no real x will satisfy this equation. So in that case, x square goes minus 1. So x will be plus minus under root of minus 1. So plus minus under root of minus 1. This under root of minus 1 is what we call iota. Under root of minus 1 is what we call iota. So this is x equals to plus minus iota. Am I clear? So this is where now this iota, this is what we call the coefficient of imagination, and its value is under root of minus 1, which is not a real value. All right. Just have a look at it quickly. So this under root of minus 1 is what we call coefficient of imagination. Now, if I have the equation like x minus 2 whole square plus say 9 equals to 0. Now, what will you do? You will say x minus 2 whole square is minus 9. So x minus 2 will be plus minus 3 into under root of minus 1. So this is what we write, plus minus 3 iota. So x is what? 2 plus minus 3 iota. So these numbers are what we call complex numbers. These are the numbers that we call complex numbers. All right. Now, as of now, we have understood every complex number z is of the form of a plus iota b. Every complex number z is of the form of a plus iota b. Now, these complex numbers can be purely real. Purely real is like z equals to 3, z equals to 5, z equals to 11 upon 2, isn't it? So in that case, b goes 0. So if a complex number is purely real, that means b is 0. Now, if a complex number is purely imaginary, so purely imaginary like z equals to 3 iota, z equals to minus 2 iota. In that case, a goes 0. In that case, a goes 0. And if a complex number is imaginary, complex number is simply imaginary. So in this case, b should not be 0. That means z can be minus 2 plus 3 iota, z can be 3 iota, Z can be minus 11 plus 7 iota. So they all are imaginary. Yes, they may be purely imaginary. They may not be purely imaginary, but they are imaginary. Now, looking at both of them, we can conclude that 0 plus 0 iota means origin. 0 plus 0 iota is the only complex number that is considered as purely real as well as purely imaginary. So 0 plus 0 iota is the only complex number that is considered as purely real as well as purely imaginary. Understood, everybody? Now let's talk about iota. Iota is what? Iota is under root of -1. So in that case, iota square is what? -1. Iota cube will be minus iota, and iota the power 4 is 1. Similarly, iota की power 5 is iota. Iota the power 6 is -1. Iota the power 7 is minus iota. Iota the power 8 is 1. Or in the same manner, if I see iota the power 9 again iota the power 10 -1, iota the power 11 is minus iota, and iota the power 12 is 1. So there is a pattern that you see. If power of iota is a multiple of 4k, then the value is 1. If power of iota is a multiple of 4k, then the value is 1. If power of iota is of 4k plus 1 times, means if you divide this power by 4, you get remainder 1. Then this will be iota. If it is iota to the power 4k plus 2, this is -1. If it is iota to the power 4k plus 3, this is minus iota. And iota to the power 4k is simply what? 1. Understood? Now, if I ask you a very simple question, iota to the power 92 plus iota to the power 90 plus iota to the power 88, iota to the power 86, iota to the power 88 divided by iota to the power 82, iota to the power 80, iota to the power 78, iota to the power 76, and iota to the power 74. What is its value? Give it a try. Take a moment.
Unknown caller.
Quickly try. Yes, anybody for the answer? One. Okay. Anybody else? See, if from the numerator I take iota to the power 10 common, you get iota to the power 82 plus iota to the power 80 plus iota to the power 78, iota to the power 76 plus iota to the power 74. And same is there in the denominator. So this numerator and denominator cancelled. You are left with iota to the power 10. That is also equal to iota square, that is -1. Understood? Now, complex numbers and its representation. See, the number of the form of z equals to x plus iota y, where x and y belongs to real numbers and iota is under root of -1, is called complex number. The real numbers x and y are called the real and imaginary part of complex number z. That means if the complex number is z, that is x plus iota y, then x is a real part and it is expressed by real parts of z. Y is imaginary part and it is expressed by this imaginary part of z. So if real part of z is x, imaginary part of z is y, and symbol iota, this is called iota. So the complex number zx plus iota y is called purely real if y is 0 and purely imaginary if x is 0. This is what I have already explained you. Now, as far the representation is concerned, this is the plane that we call Argand plane. This is the Argand plane. Now, complex number z is x plus iota y. Means, now here, this is x axis in coordinate geometry, which is called here real axis. Real axis here. Y axis is called imaginary axis here. So if I use z equals to x plus iota y, means along the real axis, you move x. Along the imaginary axis, you move y. And we get a point P, x comma y. Along the real axis, we move x. Along the imaginary axis, we move y. And we get a point P, that is x comma y. Understood? That means if you want to express a complex number 2 plus 3 iota, means along the real axis we move 2 and along the imaginary axis we move 3. You reach to this point 2 plus 3 iota. In coordinate geometry, we will be able to write it 2 comma 3. If this, say this was z1, so there is z2, that is minus 3 plus 2 iota. So this is z2, that is minus 3 plus 2 iota. Understood? So this is how we represent a complex number in the Argand plane. Now, algebra of complex number. Now, how do we add complex number? How do we subtract complex number? How do we multiply them? Now see, adding two complex numbers means adding their real part plus iota times adding their imaginary part. So if z1 is x1 plus iota y1, z2 is x2 plus iota y2. So z1 plus z2 is what? Add their real part and here add their imaginary part. Z1 minus Z2 is what? X1 minus X2 plus iota times Y1 minus Y2. Now Z1 into Z2. Z1 into Z2. Now you totally multiply it. Z1 into Z2 is X1 plus iota Y1, X2 plus iota Y2. So that is X1, X2, iota times X1, Y2, iota times y1 x2, iota square times y1 y2. Now this iota square is what? Minus 1. So this is x1 x2 minus y1 y2 plus iota times x1 y2 plus x2 y1. x1 x2 minus y1 y2 plus iota times x1 y2 minus x2 y1. This is how we multiply two complex numbers. Got it? Now, if I come to division, say I take the same example, z1 upon z2. That is x1 plus iota y1 upon x2 plus iota y2. Now see, there is no direct way to divide two complex numbers. So here also we will be multiplying. So multiply this by x2 minus iota y2 and this also x2 minus iota y2. Now, if you see into the denominator, you will get x2 square plus y2 square. And in the numerator, we multiply like we have done earlier. So that will be x1, x2 plus y1, y2 plus iota times x1, x2, y1 minus x1, y2. Understood? So this is how we divide two complex numbers. Now, as far the equality is concerned, so Z1 and Z2 are said to be equal if their real parts are equal as well as their imaginary parts are equal. But the main and most important thing is you cannot compare two complex numbers except for the equality. You cannot compare two complex numbers except for the equality. Like saying this complex number is greater than this complex number, it does not make any sense. Like here. 3 plus 2 iota is greater than 1 plus 2 iota. That is not at all sense. Getting my point? What makes sense? See, this is 3 plus 2 iota is what? This is some point in the Argand plane. This 1 plus 2 iota, this is some another point in the Argand plane. Then what do you say? This point is greater than this point. So that does not make any sense. Getting my point? So two complex numbers we cannot compare. We cannot compare two complex numbers. Yes, except for the equality. If they are equal, that's fine. You compare their real parts, you compare their imaginary parts. You can compare their modulus, but you cannot compare two complex numbers like this is greater, this is smaller. That is not feasible. Okay, write down a simple, very simple question. Find a real x and y if x to the power 4 plus 2x iota minus 3x square plus y iota is 3 minus 5 iota plus 1 plus 2y iota. Find the real x and y if this is satisfied. Yes. Take a moment and suggest me how do I do it. All right, see, just now we have compared. Collect all the real parts one side, x to the power 4 minus 3x square minus 3 minus 1. Now take everything with iota in one bracket. 2x minus y plus 5 minus 2y. This is 0. So it is x to the power 4 minus 3x square minus 4 plus iota times 2x minus 3y minus 5, 2x minus 3y plus 5 equals to 0. Now, as far the comparison is concerned, real part equal to 0 as well as imaginary part is equal to 0. So x to the power 4 minus 3x square minus 4 equal to 0 as well as 2x minus 3y plus 5 equal to 0. Now I have to solve both of them. Got it? See, this can be factorized as x square minus 4 into x square plus 1 equal to 0. So x square is equals to 4. X is plus minus 2. So if x is 2, then 3y is equals to 5 and 4, 9. That means y is 3. And if x is minus 2, 3y equals to 5 minus 2 into 2. That is 1. So in that case, y is 1 by 3. So there are two values of x and y satisfying this. That is x2, then y minus 2. And x minus 2, then y is 1 by 3. Have a look. Got it? Now, different forms of a complex number. All right. So there one Cartesian form I have already told you where we replace z as x plus iota y. Now there is a form that is what we call polar form. Now there is a form to which we call polar form. So polar or trigonometric form C. Now let us assume this is a complex number x plus iota y. Its distance is or its argument is magnitude of z. Say it is r. Now this will be what? X is equals to r cos theta and y will be r sin theta. So this z, that is x plus iota y, will be r cos theta plus iota times r sin theta. So if I take r common, it will be cos theta plus iota sin theta. This is what we call trigonometric form or polar form of a complex number. Now, this is also written as r e to the power iota theta. And this is what we call Euler form. Euler form. Understood? This is what we call Euler form. Now, conjugate and argument of a complex number. So, if z is x plus iota y is a complex number, then conjugate of z is denoted by z bar and is obtained by replacing the sign of iota. Means replace iota by minus iota everywhere. So what do you get? Z conjugate is x minus iota y. So if z is x plus iota y, then z conjugate is x minus iota y. So if z is x plus iota y, then modulus or magnitude. Now, modulus is what? Modulus of a complex number is what? That is distance between origin and z. So if a complex number z plus x plus iota y is there, then modulus of z is under root of x square plus y square and written by mod z. You can see it here. If there is a complex number, if there is a complex number z that is x plus iota y, means to reach, you move distance x along the x-axis and distance y along the y-axis. Then what will be this distance? This will be under root of x square plus y square. And that is the distance between complex number and origin. So modulus of complex number is what? Distance between origin and z, and that will be under root of x square plus y square. Okay. Let us write a very simple question. Find the locus, or find the area enclosed by the locus. Real part of 1 by z is less than 1 by 3. Real part of 1 by z is less than 1 upon 3. See, how do we do it? Let z is equals to x plus iota y. So 1 by z is what? 1 by z is 1 upon x plus iota y. Now you rationalize it, you multiply by x minus iota y, you divide by x minus iota y. So it becomes x minus iota y upon x square plus y square. So real part of 1 by z is what? X upon x square plus y square. Understood? So what they are saying, x upon x square plus y square is less than 1 by 3. That is, x square plus y square is more than 3x. So it can be written as x square minus 3x plus y square greater than 0. Now these are what? This is a circle with center as 3 by 2 comma 0 and radius also as 3 by 2. And radius is also what? 3 by 2. So every point outside this, because it shows more than 0, every point outside this circle is what? Your locus. Very good question. Have a look. Understood? Now, argument of a complex number. Now, what is argument? Before that, let me explain you on my own, then I'll show you the theory. Argument. Say, there is a complex number z that is 1 plus root 3 iota. Means along the x-axis 1, so z is 1 plus under root 3 iota. Now, if you join it with the x-axis, so this angle is what? This angle theta. Tan theta is what? Root 3 by 1. So theta is what? Pi by 3. Theta is what? Pi by 3. So what we say, argument of z is a pi by 3. Argument of z is pi by 3. Am I clear? Now see, I will show you what argument is what. Argument is the angle between real axis and if angle between real axis and line joining origin and complex number. And it is measured clockwise. So argument is what? Angle between real axis and the line joining origin and complex number and measured clockwise. So means if there is some complex number here, let us assume, then the argument will be this angle. So if a complex number is somewhere here, then either you take argument this or you measure it clockwise, anti-clockwise. Or you measured it clockwise and put an extra negative sign before that. You measure it clockwise and you put an extra negative sign before that. Understood? So argument is what? Now see, if it is x plus iota y, what will be tan theta here? Tan theta will be y by x. So argument z is given by tan inverse y upon x. Understood? The value of the argument theta which satisfies the inequality minus pi to pi is called principal value of argument. And this principal value of argument is what we call amplitude of complex number. This principal value of argument is what we call amplitude of complex number. The principal value of argument z is theta, pi minus pi plus theta or minus theta, according as z lies in which quadrant, where theta is tan inverse y by x mod. Got it? Argument of z is not unique. General value of argument will be theta plus 2n pi, because you can reach to that complex number after revolving 2 pi around the origin. So it is 2n pi plus theta. Understood? Now let us find the argument for 4 different complex numbers. Say I have a complex number 1 plus iota z1. Then I have a complex number here that is minus 1 plus under root 3 iota. Then I have a complex number here that is minus 2 plus 2 iota somewhere here. And then I have a complex number here in the 4th quadrant. Say I call it Z2. I call it Z3. And say Z4 is minus 1 minus iota. So first of all, you join this. This length is 1, this length is 1. So this angle is going to be pi by 4. Means argument of 1 plus iota is what? Pi by 4. And then you can add 2 and pi to it. Understood? Now come here. If you see this distance is 1, this is root 3. So this angle is what? Pi by 3. Now if this angle is pi by 3, the argument is going to be what? This angle. That is 2 pi by 3. So argument of minus 1 plus root 3 iota is 2 pi by 3. Got it? Now let's come here. Say your complex number is located here. That means this is 2, this is also 2. So this angle is what? Pi by 4. So now argument is minus 2 plus 2 iota is what? Pi by 4, but negative sign is also there because we have measured it anti-clockwise. All right. Now complex number is here. This is 1, this is 1. So this angle is what? Pi by 4, but argument will be this angle. So argument of minus 1 minus iota is pi by 4. Now you can add, sorry, not pi by 4. That is minus 3 pi by 4. First of all, this angle is what? This angle is 3 pi by 4. Then you are measuring it clockwise. So it will be minus 3 pi by 4 and plus 2 n pi. So here also I can add 2 n pi. Here also you should add 2 n pi. So these are what? Argument. And now if you do not add 2 n pi to it, it will be the principal value of argument. That is pi by 4 or simply 2 pi by 3 or minus pi by 4 and minus 3 pi by 4. Understood? Now, properties of argument. See, if z is purely real, then argument of z will be either 0 or it will be pi. Because there is no imaginary part of z existing. Understood? So, if a complex number is purely real, that means its argument will be either 0 or pi, depending upon if your complex number is lying on positive real axis or negative real axis. Understood? Now, if z is purely imaginary, then argument of z is plus pi by 2 or minus pi by 2. If z is purely imaginary, then argument of z is plus pi by 2 or it is minus pi by 2. Got it? Now, argument of z1, z2 is what? Argument of z1 plus argument of z2. Got it? Its proof is due to me. I will explain it proof in the next lecture because there I need to require something, to impart some more knowledge before explaining it. So this property, this property, this property, and this property, they all I will explain in a while. You just remember one thing, argument follows the kind of rules that log follow. Log AB is also what? Log A plus log B. Log A upon B is what? Log A minus log B. Now, properties of modulus. See, modulus of any complex number will always be more than equal to 0 without any doubt. Modulus of a complex number z is greater than real part of z or it is equal to real part of z. Similarly, modulus of z will always be greater than imaginary part of z. Now see, modulus of z is also modulus of z conjugate is also modulus of minus z is also modulus of minus z conjugate. Got it? Then, very important. Z bar is magnitude of z whole square. Z bar is magnitude of z whole square. You can simply prove it. If the complex number z is x plus iota y, z bar is x minus iota y. So z bar is x plus iota y into x minus iota y. That is x square plus y square. Am I clear? So that is x square plus y square. Now, again, this property of modulus, this property of modulus, and this property of modulus, I will explain with the properties of argument. Understood? Now, properties of modulus. Z1 plus Z2 conjugate, Z1 plus Z2 magnitude square is Z1 square plus Z2 square plus twice plus Z1 Z2 bar plus Z2 Z1 bar. See this property. Z1 plus Z2 magnitude square. This is it. Now, just now we have seen that magnitude of z square is zz bar. So you can write it z1 plus z2 into z1 conjugate plus z2 conjugate. Now, if I multiply it, it will be z1 z1 conjugate plus z1 z2 conjugate plus z2 z1 conjugate plus z2 z2 conjugate. Understood? So now z1 z1 conjugate is what? Magnitude of z1 square plus magnitude of z2 square plus I can write it real part of z1 z2 bar, because these two are what? They are conjugate of each other. Conjugate of each other. So this is twice. So if you add z plus z conjugate, what do you get? You get twice real part of z. Means if I add x plus iota y and x minus iota y, what do I get? 2x, that is twice real part of z. So this is also what? Twice real part of z1 z2 conjugate. This is what? Z1 plus Z2 magnitude square. Similarly, if you do Z1 minus Z2 magnitude square, you get mod Z1 square plus mod Z2 square minus 2 real part of Z1 Z2 bar. Got it? So the second property is Z1. First property is this, and written in the form of real part of Z1 Z2 bar or Z2 Z1 bar. Then Z1 minus Z2 square, mod square is this. This is equals to what? This will be 2 times. Some mistakes is written. This is 2 times real part of Z2 Z1 bar. Now if I add both of them, yeah, this is not really important. This is not easy to remember. Leave this one. And finally, if I add both of them, what do I get? Z1 plus Z2 magnitude square plus Z1 minus Z2 magnitude square is twice of mod Z1 square plus mod Z2 square. Very, very, very important property. Have a look. Priya, understood? Ishrat? Ishrat? Priya, you understood? All right. That would be all from my side today. Today we have started with complex number, understood their representation in trigonometric form, polar form, and we understood their modulus, what is their modulus or magnitude, argument, and amplitude, and what are the conjugate. How do we express complex numbers? How do we apply algebra on them? So that would be all for today. Now just a small feedback about this class I require.